Now, as we get into this next section, a couple things you need to be aware of is that when we look at an object's position relative to something else, we have to both indicate the distance and the direction. So when you are trying to tell somebody where something is located, you can't just tell them how far away it is. You have to tell them in what direction. And so for points on the number line, the distance we move away from is the origin. And we can move either to the right, which is positive, or to the left, negative. So we know all of this. This is just some terminology you need to think about as we move into this next piece, because now we are going to look at this symbol here, absolute value, which you're probably familiar with. And for absolute value, you're strictly talking about distance, specifically distance from the origin. And so this is why when I say absolute value is always positive, it's because we are not telling a direction when we're talking about absolute value. We are simply telling a distance. And so if I am looking at 0 and I want something that is 3 units away in any direction, that means I can be 3 units away in the positive or the negative. So when I have an x inside of here, that x could be -3 or +3 because those are both 3 units away from the origin, not talking about direction. The absolute value then is defined this way. It is just going to be what's inside if that number or if that variable is greater than or equal to 0. And it's going to be the opposite of what's inside if it's less than 0. So when we talk about solving these, that means that what is inside of here could be 9, because that is 9 units away from the origin, or it could be -9, because -9 is also 9 units away from the origin. So when I solve these, I have to think about the fact that I could be 9 in any direction here. And so X is going to have two answers here. X is going to be 4 or 14, because when you plug either of those in, you get a number that is 9 units away from the origin. If you were to plug it back in, you would see that 4 plus 5, yep, that is 9 units away. And then -14 plus 5 is also 9 units away from the origin. So the absolute value quantity has to be completely isolated before you do this step. You cannot go ahead and solve it with two different things unless it is isolated on one side of the equation. And then you're going to rewrite it as a disjunction of two equations. And so the first thing we want to do here is we want to look at what is our absolute value. Well, our absolute value is this piece right here. And so we want to get rid of everything that is not a part of our absolute value first. In this case, we have a -8 or a -8 here that we need to get rid of. And so we're going to subtract that 8 over. We still have the 2, we still have the absolute value, but it is now equal to 32. We also have this 2. Now remember, when you do not see an operation here, it is a multiplication. So to get rid of this 2, I am going to divide both of these sides by 2, and I will end up now with that absolute value equal to 16. Now, once you have it at this point, you are now ready to set up those two equations and solve. And so I'm going to set up those two equations. Remember what's inside would equal 16. That would be 16 units away from the origin. But what's inside could also equal -16, because -16 is also 16 units away from the origin. And then we have pretty basic equations to solve. We're going to add 12 to both sides. Here we get 3x equals 28. When we divide, it doesn't matter that it is a fraction. Fractions are fine. X is 28 thirds. And then on the other side, if we add that 12, we're going to get 3x equals -4. And we are going to divide by 3. And we're going to see that x could also equal -4 thirds. And so as you start solving these absolute values, you want to make sure you're getting those absolute values completely alone before you move on to set up those two equations. Now, Once you have your absolute value by itself, it cannot be negative because remember, absolute value is talking about a distance away. Now, we're not talking about what's inside. The absolute value itself cannot be equal to negative, or you have a problem here. And the problem is you would not have a solution. So let's look at this example here. It says 2x plus 9 equals 3 minus 8x. Now, what I want you to do first here is recognize that this little guy is going to be a group for you because technically I have my absolute value all by itself. And so I am going to take that 2x plus 9 and I'm going to set it equal to the 3 minus 8x. But in order to do the negative piece of this one, I need to make sure that I negate the entire group here. So here it didn't really matter on this side, but over here it matters that you group it because you're going to distribute that negative when we get there. So over on the left here, I can add that 8x to both sides. To get my variables on one side, I have a 10x plus 9 equals 3. And then when I subtract that 9 over, I get 10x equals negative 6. And then I'm going to divide both sides by that 10, and I'm going to get x equals negative 3/5. Then let's look at the other side here. I again have 2x plus 9, but now I have negative 3 plus 8x. And so this is going to change my problem to have a different answer. I'm going to subtract that 8x over. Over here, I have a negative 6x plus 9 equals negative 3. When I subtract that 9, I get negative 6x equals negative 12. And then when I divide, I get x equals 2. So I have two possible answers here. I have negative 3/5 and positive 2. So one of the things you want to make sure that you do, especially when you have an x that is hanging out over here and it is not inside the absolute value, is you want to make sure that you check your answers. And so it can be a bit tedious, but you want to make sure you do. So if I were to plug this 2 back in, 2 times negative 3/5, I'm going to add the 9. That is inside the absolute value. That equals 3 minus 8 times negative 3/5. You are going to have to do some fraction work here. But what you're going to do is you're going to find that you get the absolute value of 39/5 equals 39/5. Well, that is true. All right. But when we do the same thing for this 2, we would say 2, plug in the 2, it's 9 equals 3 minus 8 times 2. When you do your order of operations, you're going to get the absolute value of 13 equals negative 13. That is not true. So this answer does not work when you plug it back in. Only this answer works. And so when you have an answer that you solve for, but it does not work, this is called an extraneous solution. So an extraneous solution is one that you got from setting those two insides equal to the positive and negative. But when you plugged it back in, it did not make your statement true. And so extraneous solution is not a solution, it's a false solution. And that's when you need to make sure you check these because you can get extraneous solutions in these problems. So let's look at this general approach. You want to isolate the absolute value. You want to set the expression inside equal to either that constant or the negative of it. And then you want to solve both equations and make sure when you're solving equations that you do that final step of checking those equations. The last two things I want to look at with absolute value is distance. The distance between 2 points is the absolute value of the difference of their coordinates. So distance means there's no direction. and you are just talking about the absolute value. And then you also have a midpoint. So the midpoint is just the average between the 2 points. Pretty straightforward. So for like the general equation here, we're going to say just subtract those two and take the absolute value. And then you are a certain number of units away from the midpoint. So if you take one of these endpoints and subtract that midpoint, that's how far away you are from it. Let's look at write an absolute value equation representing this graph. Well, if we look at the midpoint here, we would just say, what's the average? So the midpoint is going to be 5 plus -1 divided by 2. The midpoint here is 2, all right? Which means that that the distance from either given point to that midpoint is going to be the absolute value. Let's say we just take a 5. 5 minus the midpoint of 2, this is where we found the midpoint right here, is going to equal 3. Or if we had done it from -1, the distance here would be -1 minus 2. That's also 3. All right. So if we wanted to find an equation that represents this whole entire set of numbers, you would, instead of using an endpoint there, you would say, well, x minus 2 equals 3. And if you were to solve this back, you would get those two endpoints. So this graph, this equation represents this graph right here.